Scientific notation. We have learned different ways to write numbers. We've learned standard form, in which we may write a number 5 times 5 times 5 times 5. We know we can go from standard form to exponential form by bringing our base down. And adding the number of times the base was used as a factor to get our exponent. So in this case, our exponent is 4 because 5 was multiplied 4 times. Scientific notation is a way to represent very large or very small numbers. What do you mean, Miss Griffith, right? Well, let's say, for instance, we had a number that looked like this. 4,860,000,000. If I were to ask you to write this number down several times, adding, subtracting, multiplying, dividing it, or just writing it over and over, you could lose track of how many zeros there are. Scientific notation provides us with a way to write this number that doesn't have all the repeating zeros. It works with very, very large numbers and very, very small numbers as well. When writing numbers in scientific notation, they all have a common form, and this form is a number times 10 with an exponent. The times 10 part never, ever, ever changes. It'll always be times 10. The first number has rules, and the rules for this number are they have to be greater than or equal to 1. So it can be 1, but it has to be greater than 1. And it has to be less than 10. Also, we have rules for the exponent as well. One common misconception about this exponent is that it's ever how many zeros are at the end of the number. For example, if we were given this number, a lot of people would say, ooh, there's 4 zeros. The exponent has to be 4. No, no, no. The exponent is the number of times the decimal is moved. Okay, so now let's put all these rules together and turn this number into a number written in scientific notation. We know that scientific notation will be in the form of a number times 10 with an exponent. And it's our job to fill in these blanks using the rules that we just stated. Looking at this number, in this number I don't see a decimal anywhere. Where do we assume the decimal is? That's right, it's at the very end. If we look at this number now, this number will not fit in this spot because it is greater than 10. So we need to move our decimal point to make it into a number that is greater than 1 but less than 10. If we move it behind the 3, that gives us 563. Again, that number is greater than 10. If we move it between the 6 and the 3, that gives us 56.3, a number greater than 10. If we move it between the 5 and the 6, that gives us 5.63. Well, 5.63 is greater than 1 and less than 10. So that satisfies the rules for the first number, 5.63 times 10. Now remember, we're not going to put the exponent 1, 2, 3, 4, 5, 6, 7, 8. We're not going to put the exponent of 8 because there's 8 zeros there. No. Remember the exponent. We get it by counting the number of times we moved our decimal point. We moved our decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We moved our exponent 10 times, so 10 is our exponent. Questions? Okay, let's look at this example. In this example, we have a very, very small number. If we go to put this in scientific notation, we know it's going to be a number times 10, always times 10, with an exponent. We can't put this in this blank because this number is less than 1, and we know that the number before the times 10 has to be a number greater than or equal to 1. So we've got to move our decimal point. If we start moving our decimal point to a place to satisfy this rule, we can stop between the 6 and the 5 because 6.54 is greater than 1, greater than or equal to 1, and less than 10. 6.54 is less than 10. So now what we have to do is put in our exponent. If we look at this, we moved our decimal 1, 2, 3, 4, 5, 6 times. So we have an exponent of 6. However, what do we remember about this? That's right. Anytime we have a number that's less than 1, we know that the exponent will always be a negative. So when we write this in scientific notation, we're left with 6.54 times 10 to the negative 6. Okay, now that we've done a couple examples, I want you to work some problems on your own. I've given you 4 numbers written in standard form. It's now going to be your job to write these numbers in scientific notation. Once you have these 4 numbers written down in scientific notation, I want you to bring them to class tomorrow, along with any questions that you may have. And as always, remember, be the Fruit Loop in life's bowl of Cheerios.